Use a resistor as a load, to ensure that the signal sources are working properly. Bring a sine generator from generator mode. The sine signal generator supports this equation. You can use an oscilloscope to view the waveform. You can adjust the oscilloscope when performing the simulation. Add a pulse signal. Pulse signal generator has these features. For better compare the waveforms, align all three channels. You can print oscilloscope page information. But another way is, to view the waveform through a graph. This method uses voltage probe. Choose a name for the probes and signal generators. Now, drag the voltage probe onto the graph, and drop it in the upper left corner. Double-click on the title bar of the graph. For better view the waveform, from the Edit graph, set the scan time, From 0 to 3 milliseconds. Adjust the vertical axis range. For more clarity, you can change the color of different parts. One volt offset for sine wave. The crossover can be used for more accurate measurements. Delay or phase for sine waveform. Press the spacebar key on the keyboard. Delay for pulse waveform. Rise time and fall time of the pulse wave. Damping factor for sine wave. Set the scan time from 0 to 2 seconds. Let's remove the pulse wave. Let's add a pulse wave trace to the graph. You can specify the number of complete cycles to be displayed on the graph. Select 2 complete cycles for both signals. You can specify the pulse width. For example, 60%. Let's reduce the rise time and fall time of the signal. You can see different combinations of waveforms on the graph. Define res1 as the sum of 2 signals. Adjust the vertical axis range. Define res2 as P1 plus P2 asterisk P1. Set the vertical axis range between -10 and 15. You can get export form the graph. You can choose different formats, for example select bitmap format. Select the current graph. Thanks for watching. If you are interested in the topics of this channel, do not forget to subscribe.